Let's talk about microservices in NestJS. Setting up microservices in Nest is actually quite easy for people that have developed within a microservices architecture before. However, for those that are just getting their feet wet, it can sometimes be a bit intimidating. In this video series, I'm going to walk you through the process of setting up microservices with various configurations, and by the end, you should be able to set up and configure NestJS microservices on your own. Given that microservices is not simply a feature, but rather an actual change in application architecture, I think it makes sense that we have a quick review of microservices at a conceptual level so that you understand the pros and cons of microservices and how it affects you as a developer. So let's start with this sample dashboard application. With just a quick glance, I can immediately identify some of the major features. For example, I can see a search feature, there's definitely a messaging feature, and some sort of analytics feature I see over here. If I were to sketch this out, the initial draft would probably look something like this right here. So in a standard web server setup like this, we have a router that receives a request and passes them to the appropriate controller. The controller will likely perform some basic input validation and then call one or more services to perform some actions. And this is a good pattern to follow, right? This very basic pattern of adding a service layer, because it's a good practice to keep your controller logic declarative, meaning that you should say what you want to do, but leave the implementation of how those actions are performed to another class, usually located in a service. In a traditional monolithic app, these services are either reside in the application code or included as dependent libraries. The most important thing to note here is that the code is accessible by the app and executed by the main process of your app. And that's what a monolithic app is. It's everything running in a single process. In a nutshell, moving to a microservices architecture means that you extract your service classes and you put them into their own processes. If we were to do something like that with what we see here, we'd probably get something that looks like this. As you can see, the logic flow is exactly the same. The only real difference is that the services are running in their own processes. And on the surface, it seems kind of like a simple change, but the implications are pretty big. So, if you think about it, what are the implications of this? Why would this be a good thing, right? First thing I can think of is a scenario for very large projects that have multiple teams of programmers. Perhaps like an entire team is dedicated to the analytics service. Maybe one or two devs are assigned solely to the search and messaging service. And maybe the last team kind of like focuses on the web server itself. By splitting these components into their own processes, that means they can have their own repo and be managed completely separately. Each can have its own policies regarding PRs, each can have its own testing and deployment schedules, etc., etc., etc. Since it can be managed separately, no coordination is required across the team to manage a deployment schedule. Another advantage, and the one you probably hear the most about, is improved scalability. Having features run in separate processes means that the DevOps team has a lot more flexibility in how they manage that load. That is, they can scale the services individually instead of having to replicate the entire app during that scaling process. Okay, so those are a couple of the advantages, but architectural decisions are really about trade-offs, and it's important to know both the pros and the cons of any design decision that you make. So what are the disadvantages of splitting things out into their own processes like we do in a microservices architecture? The first thing that comes to mind for me is the additional complexity related to testing. You could probably do a Google search for something like microservices testing hell. And you'll come across more rants and doomsday prophecies than you could read in a lifetime. And it's true, testing does get more complex in a microservices architecture. But for enterprise scale apps, truly enterprise scale apps, it's usually worth accepting these headaches in order to make the infrastructure side of the equation more manageable. But I don't want to spend too much time listing these kinds of things. I'd rather focus on one particular disadvantage that directly impacts you as a developer. Do you have any idea what it is? Well, when your service logic is executed in the same process, it shares the same memory location. To access the service, you simply inject a reference to the instantiated object in your controller. This is simple, straightforward, the normal course of business, right? But when you extract that service logic code into a different process, you can no longer use it the same way. That other process, being a separate process, does not have access to the memory that the main process uses. Therefore, we have to find some sane method for communicating between these processes. And this is the focus of this video series, because this is really what setting up microservices is all about. In the video series, we're going to demonstrate how to set these separate processes up and how to properly communicate between them. So it's really important that you understand this part. Let's look at an example of just a basic controller to ensure that we're on the same page before moving forward. So if we look at this controller, you have a controller class that injects a service in the constructor. Then we've got a single method mapped to the hello route that calls this injected service and returns the result to the user. This is a common pattern for controllers in monolithic apps. Well, actually, it's also a common pattern with microservices. The difference lies in what you're injecting. So what are we injecting here? Well, in a monolithic app, the code for the service is executed within the same process, right? So it's no different from injecting anything, right? You just inject a reference to an instantiated object that's probably in a container somewhere, right? And then you just start calling methods on it. Business as usual. But in a microservices architecture, we're in a separate process. We cannot do that. So what are we going to inject in the controller? So what are we injecting? In a microservices architecture, instead of injecting a direct reference to the service logic itself, what we're actually injecting is a microservices client that knows how to contact the appropriate service and get a result. This client will be configured to use one of several transports to contact the required service. For the most part, what transport you use doesn't really matter. It's just important that the client and the microservices server be configured to use the same one. So let's talk a little bit more about transports. What's available in NestJS? The supported transports are the ones you see here on your screen. There's currently 6 of them, but they could probably be broken down into really about 3 categories. One is the direct, which is you're just using TCP to directly connect. Those in the middle are pretty much all message brokers, or a product that has a message broker that it can use for communicating. And the last would be a remote procedure call with gRPC, which is a slightly different beast than the rest. I'm not going to get too deep into it because we're going to have a video dedicated to it. But just kind of think of it, gRPC as a cool way to try to abstract all of this complexity away and make it look like the microservice is actually residing in the same process. So it kind of lets you follow the same programming flow. I hope that's not confusing. Again, we'll get into it in a separate video. So, key takeaways. 1, microservices are run as separate processes. To get the goodness out of microservices, the main issue you're going to face as a developer is, okay, how do you connect them and have them talk to each other, that inter-process communication. That's going to be the big focus of getting started with microservices. Since we have separate processes, we're actually going to have separate projects. So we'll have one Nest project for the web server and one Nest project for the microservices that we develop. In this video series, we're just going to use one microservices and one regular Nest project that uses that microservice. And also that there's the other thing to take away is that there are several transports. We're not going to check every one of them off, but we're going to do 3 in this series. We're going to look at direct TCP. We're going to use a message broker. I'll be using Redis in that example, and then we'll be moving on to gRPC. And what's the agenda for this tutorial? Well, actually, I think I already just told you, but let's look at it again. So this video that we're in right now, Introduction to Microservices, Next video up is going to be how to set up microservices using TCP. Then we're going to move on to adding a message broker in and communicating through a message broker. I'm choosing Redis for that. And then after that, we'll look at gRPC, which is a little bit more complex to set up, but offers some really cool features. So I think that's about it for this video, guys, and I will see you in the next video.